Hey guys, Bungy here, and welcome to another episode of No Accent Tutorials. Today I'll be showing you guys how to normalize into third normal form in database relation. Okay, so we have a pretty basic relation here with A, B, C, D, E, F, and G. We have three functional dependencies. So how would we start off normalizing these functional dependencies and relations? Okay, so step one is to right-hand side simplification. Okay, a right-hand simplification is as simple as it sounds. It basically means that you're getting your functional dependencies and you are atomizing the right-hand side, meaning that AD implies CF becomes AD implies C and AD implies F. Okay, this is a part of minimal cover. And that is what you have to do in order to get your thing into third normal form. So, but that's only a part of it. Let me just write that out, minus the bit where I just repeated the question. So this becomes AD implies C, AD implies F, A implies B, E implies GA. That's as basic as you can get. Okay, now, step two is to left-hand side simplification. There is a specific algorithm to this, and that is you have to delete dependencies where there are attributes with no identity closures. So basically that means if AD implies, just change the color. So basically if we have AD implies C, if A does not imply C, but D implies C, then we can get rid of A. Like that's that simple. Okay. What we have now is AD implies C, and this can become, so we first must check the closure of both A and D. So A closure is going to give you B. Reflexivity, which gives you A, you're going to get B, and that's basically all that you're getting. So as you can see, A does not imply C on its own. Let's see if D implies C on its own. Okay, so D does not imply anything, which means that AD must stay the same. That's pretty simple. Okay, now we have AD implies F, and based off the same rule, A on its own does not imply F, as it only implies B, and D on its own does not imply F either. So it is yet another functional dependency that should remain the same. So what you now have is AD implies F, so that stays the same. So next we have A implies B, and that is unique as well. A implies B. We have E implies G, which is unique and non-trivial. And then finally we have E implies A. and that also implies B. Because A implies B, then that should remain the same. Okay. Now, the third step is to delete the redundant functional dependencies. Delete redundant functional dependencies. And what does that mean? It basically means to pretend that there is no such left-hand side for each functional dependency. If there is another way to get right-hand side with the remaining functional dependencies, then remove that entire functional dependency. Okay, so we're going to start off with the first functional dependency, which is AD implies C. Is there another way to get C without the need of AD? There is none, so it just stays right there. Okay, what about AD implies F? Is there another way to get F without AD? I don't think so. So AD implies F. Okay, A implies B. Is there another way to get B without A? No. Reflexivity. If you have B itself, then you have B itself, but that does not mean that you can imply B from anything else. So A implies B. Can you get G from anything else? No, you cannot. Which means that E implies G stays the same. And E implies A. If I cover E, then A, is there any way to get A without E or itself? Nope. Which means that E implies A. Okay, now we have these functional dependencies. We will continue to step 4. Step 4 is to create relations for each functional dependency. Okay, create relation for minimal cover. And this here should be your minimal cover. Oops, handwriting typo. Ah, my goodness, my hand. So this is your minimal cover. It's pretty straightforward, isn't it? Okay, create relations for minimal cover. So we have our relation 1, ADC. We have relation 2, ADF. We have relation 3, AB. We have relation 4, EG. We have relation 5, EA. And we have those. And step 5 is to create relations for missing candidate keys if it excludes the right-hand side. Okay, so basically we have to first and foremost find a candidate key, which I have covered in my previous video, so please go and check that out. But I'm just going to compute the candidate key for this one. So CK is going to be AD implies C and F. A implies B. E implies GA. Oops. OCD is hitting me very hard right now. Okay, so E implies GA. So E implies G, and E implies A. Okay, so A has a tail, B has a tail, C has a tail, F has a tail, G has a tail. Okay, so the two candidate keys are D and E, which means that D and E are candidate keys. D and E are candidate keys. Okay, so D and E are candidate keys. We've established that. So now let's see if any of these relations contain the candidate key. And that does not appear to be true. So we must now create a new relation for the missing candidate keys, if it excludes the right hand side. Okay. What we can do now is we can have DE as the candidate keys. Okay, we create just DE as its own relation. So we have R5, R6. Okay, now step 6. Step 5 is to combine the right-hand sides for all relations where the left-hand sides are the same. Okay, this is pretty simple. Okay, so we have R1. We're going to have R1 A DC. ADC and F, like so. R2 AB is just on its own, so it's AB. R3 is going to be EGA, because it's a combination of these two. Combination of these two creates this one here. So okay, that implies this. Okay, so that's the those are the latest candidate keys for the relation, latest relation. Okay, now we have finally we have D and E. So we have R6, which is just becomes D and E. Okay. Okay, we have R1, R2, R3, and R4, and those are the latest relations. Okay. Now, if I am not wrong, then those should be the candidate, my apologies, in third normal form already. Okay. Okay, that should be in third normal form. Okay. This should be in third normal form. So, that concludes this video. Please note that there are more complicated scenarios which there will be more steps to be undertaken, and it will be more difficult to do. So thank you guys for watching. Please don't forget to rate, comment, and subscribe if you wish to see these videos in the future, and see you next time in my videos.